Hi, this is Raj Sharma, and in this session, we will discuss the OOPS concept encapsulation in .NET C Sharp. First of all, we check encapsulation. Encapsulation means we can hide the data in an enclosure so that that data is not visible to the outside of the enclosure. As you can see in the example, we have a capsule. In that capsule, we have a medicine. So, end user, the content of the medicine or the medicine is not visible to the user. User can see only the shape of the capsule. The same way, in a like C# language, we can hide the some information, some important information, say variables, methods, so that those variables and methods are not accessible outside of the class. This is called the encapsulation. Now we take the another example of the real life. So there is a car. We can see the car, we can see the design of the car, we can see the model of the car, and we can drive the car. But there is a complex part in the part that is the engine. And in engine, there could be multiple parts. And each and every part has its own function. So those complex part has been hidden from the end user. As a driver, we can drive the car, but we cannot check which part of the engine is working what function. So hiding the complex part of the engine is called the encapsulation. Encapsulation. This is implemented by using the access specifier. What are the access specifiers? Using the access specifiers, we can decide the visibility and accessibility of the each and every methods and the variable. So as you can see in the diagram, we have the different type of the access specifiers. First one, public, private, protected, internal, and the protected internal. So we will discuss all these one by one. The functionality of the private access specifier we can check with this diagram. So we have a class and private variables, private methods. So these private members cannot be accessed outside of this class. Now we check the practical of the encapsulation with the private access specifier. So private variables or private web members can be accessed only within the class. So we have a class that is the employee. In this class, we have the some variables, private EMP ID, private EMP name, private EMP code, then public EMP address and public EMP mobile number. It means we can access public variables outside of this class but not the private, because we are hiding or we are protecting the data which cannot be accessed from outside of this class. So these data are the EMP ID, EMP name, and EMP code. We have a function that is a public EMP name. And in this function, we have that private variable that is the EMP name, and we are assigning a value that is a John. Then we are returning the EMP name private variable to this public function EMP name. Now, we have a class, another class. And in this class, we have the main method. In main method, we are creating an instance of the employee class this. Now we check which members can be accessed or which members cannot be accessed. So we created the EMP. Now EMP dot. So if we check this list displays all the members, public members, which can be accessed. So we have the EMP address. It's a public, EMP mobile number, public, and EMP name. It's a public method. It means only these three variables and the methods can be accessed, not the private. If I try to say right here EMP dot say EMP ID, now we have an error because this EMP ID is a private and cannot be accessed. We access EMP dot EMP name, that is the public method. Now I execute this program. So as you can see in the console, we have a message, the employee name is Johan. So this is the public methods we can access the in another class. But through the public members, we can access the private members of the other class. So we can check the scope of the public variable with this diagram. So public variable, it allows all members, its member to be visible from anywhere inside the project. It means if the variable is public, then it can be accessed inside the class and outside from the class. Now we check the encapsulation with the public access specifier. So already we have a class that is employee, but some members are private and some members are the public. It means we can access only the public members. Public members is also visible outside of this class. We have an MPID that is the private, and also we want that this MPID should be visible to outside of this class. Now if I try to this EMPID, EMP dot, then this member variable is not visible outside of this class because that variable is a private. So if I make it a public, say EMP code, now I make it public. Okay. Again I check here, dot EMP code now is available. Say equal to 1000. Now EMP dot, say EMP ID, because this is the public. I execute this program. So you can see in the console the message is employee code is the 1000. So this is the public. We check the scope of the protected variable. So we have three classes: class 1, class 2 and class 3. In class 1 we have three variables: private, A, public and the protected. So class 2, we can access two variables B and C from the class 1. The protected variables can be accessed only in derived class. So in class 2 we are inheriting the class 1. That's why we can access the C variable because that is the protected in the class 1. But in class 3 we can access only the public variable from the class 1 but not the C, because this class 3 is not inheriting the class 1. We check the encapsulation with the protected. So protected members can be accessed within the class and the other class, or say derived class. It means that if the other class inherits the employee class, then in that case that derived class can access the protected members of the employee class. So for now we have only the public and the private, and this is the methods get emp name. Now I make it the protected. If I try to access this get emp name methods with this instance emp dot, then this method is not available because this is a protected, and this protected can be accessed only the derived class. So if I inherit this employee class employee, now this employee main, this is the derived class, and the employee now is a base class or the super class, and the protected member of the superclass can be accessed in the derived class. But now we cannot create the instance of this employee. We should create the instance of this class because now this class is inheriting the all the members, all the property of the employee class. So we will create the instance of this employee main. If I try to access the get emp name method, now we can access the protected member of the employee class because employee has been inherited in the main class. So employee name get emp name. This is the method name, but still we cannot access the private members of the employee class. If I execute this one, so we have a message, the employee name is the John. Again, if I like say delete this one, inheritance, so we can see again we have an error on this line, get emp name. This because this method is protected and we cannot access without the inheritance. Now we check the scope of the internal with this diagram. We have two assembly 1 and assembly 2. In assembly 1, or we can say the package 1 or package 2. In assembly 1 we have the two class 1, class 2. Assembly 2 we have class 3. In class 1, we have two variables, internal string A, public string B. And class 2. This class 2 can access both variable internal and public because both class are in the same assembly. But in assembly 2, class 3, variable C internal, variable D public. If we import the class assembly 2 in the assembly 1, then we can access only the public variable, that is the D, but not the C, because that is the internal in other assembly 2. This variable C is valid only for the assembly 2, that is the internal. Now we check the internal. Internal members can be accessed within any class, but within the same assembly. So right now you can see we have a two class, assembly 1 class, then the class program, and these two class are in the same assembly, that is the assembly 1. So if I create the instance of this one, assembly 1 class, object 1, now object 1 dot emp address, then object 1 dot emp code, and object 1 dot emp name. So these are the three variables, and emp code is the internal, but this class, it is on the same assembly, so that's why we can access the internal emp code in the different class. But we have that another assembly, that is the assembly 2, that is the class library. If I check the class of this one, so namespace is the assembly 2 and the class is the assembly 2 class. Okay, I take some variable, I've taken the same variables, the public, and again the emp code is the internal. So we have the different assembly and different class. Okay, back to the assembly 1. Now I want to use this second assembly in this assembly, so I have to take the reference. So add reference, then project and assembly 2. Okay, so it is done. Now I import this one using assembly 2. Now in assembly 2, I have a class, that is the assembly 2 class. Object 2 new. Okay, object 2 dot, then emp address, object 2 emp name, now object 2 dot emp code. So you can observe we have an error on the emp code because this is the second assembly, because this is the other assembly, and this emp code is a internal, so we cannot access the internal variable from the other assembly. So that's why we have an error on this code. Now next one is the protected internal, and we can check the scope of this protected internal with this diagram. So we have the assembly 1, assembly 2, two package, and in assembly 1 we have three class 1, 2 and class 3. In a class 1 we have the protected and the public two variable A and B, C. In the class 1 we have the two variable protected A and the public B. In class 2 we can access both variable because these are the same assembly. This class 1 is the same assembly. And in assembly 2 we have the class 4. We have two variable protected C and the public variable, that is the D. So we cannot access the C variable in the class 2 because that is the protected. and there is a rule for the protected. If the variable is protected, then that class should be inherited. In class 3, we are inheriting the class 4 from the assembly 2 because we are importing the assembly 2 in the assembly 1. Then class 3 of the assembly 1 can access both variable because the 4 is inherited. So it can access the both variable protected internal C and the public variable D. Now we check the practical of the protected internal. So we have an assembly that is the assembly 1 and we have an internal, then I make it protected. Protected internal string EMP code. So still I can access EMP code in other class program because the both class, the program and the assembly 1 class is in the same assembly, same package assembly 1. Now I go to the assembly 2 and assembly 2 I make it protected. I make it all protected. Back to the assembly 1. Now we can see we have error on all variables because all variables now is a protected internal, and there is a concept for the protected internal. If it is the protected, then that class should be inherited. So assembly 2 class. Now assembly 2 class, it's a base class and now program is a derived class. So we should make the instance of the derived class now. If I write say program now we can see error gone. It means we can access all the variables because all these variables in the assembly 2 are the protected internal. Guys, this was all about the how to hide or protect the data using the encapsulation. Thanks for watching the video.